1B, circuit analysis. Now this is a parallel circuit. It's a parallel circuit because all the connections are in parallel. There's a connection between resistance 1 and resistor 1 and resistor 2 that's in parallel with each other. They are in parallel with each other and in parallel with the battery. So this is a pure parallel circuit. I filled in my givens. Notice that I didn't care to write the details of the significant figures of the givens. The 5.0 I just wrote as 5. I don't care about significant figures of givens. I just care about the significant figures of the final answers. So notice that this table is exactly the same givens table as the previous question, but our answers are going to be different. Our mathematical statements are going to be different because the connections are different. Once again, though, vertically, we're going to use KVL, KCL, or equivalent resistance formulas, horizontally, Ohm's law. So the first step would be to fill out resistance, the equivalent resistance, since that's the property of electricity that we have the most information. So equivalent resistance. Now, in this case, we do not just add up the 5 and 7 ohms. They are not in series with each other. So the formula is 1 over R equivalent equals 1 over R1 plus 1 over R2. I sub in that 1 over 5 ohms plus 1 over 7 ohms, 1 over R on my calculator. Now I have this trick that I really don't want 1 over R. I want R, so I'm going to use my reciprocal button right away. So I'm going to write that as this. The reciprocal button is the same as taking the entire thing to the -1. So I really need you to try right now on your calculator to see if you get the same answer, which would be, I think I've just, okay, disaster averted. I thought I wrote the wrong givens. Okay, we're back. So resistance is, we're going to do on our calculator 1 divided by 5 plus 1 divided by 7, and then we're going to press the reciprocal button or do to the power of -1. So for the equivalent resistance, I get 2.9167 ohms. Now I do not get 0.3 something. So if you got 0.34, what you solved for in your calculator was 1 over resistance. Remember to take the reciprocal because the equation is 1 over. So for that number, when I'm putting it into my table, I am going to round it to 2 significant figures. And of course, I should have headers on my first row. I should have units on my header. I've rounded to 2 significant figures in the table, but if I need to carry forward a number, which I am saying this because we are going to use all of these digits, or in fact, there are more digits on my calculator. I'm just going to use the answer button. So the second step, once again, is to work horizontally. So our second step is Ohm's law. Ohm's law to find I source. If V equals IR, then I equals V over R. 6 volts divided by, now I'm only writing 2.9 ohms because there's not enough room, but I'm going to use the answer button on my calculator. 6 divided by answer button is 2.05714 amps. Again, when I go to write it in my table, I'm going to round it to 2.1. However, I'm going to carry forward the full answer in case I need it. So applying KVL or KCL would probably be our next step because Ohm's law, we can't move forward. We don't have 2 out of the 3 for any rows. Vertically, KVL, KCL, those are our only options. So for KVL, it's pretty easy. For the third step, KVL tells us that V source is equal to V1, which is equal to V2 because it's just a simple parallel circuit there. And now, since I have these two to fill out, I have 2 out of the 3 of these rows, and I can use Ohm's law. So number 4, I'm going to use Ohm's law to find I1 and I2. So V equals IR. That means I equals V over R. So for I1, that is 6 volts divided by 5 ohms. And we get 1.2 amps. Now, the very last box, we have more than one option. Oh dear. Okay. We have more than one option for this last box. We could use Ohm's law horizontally, which is probably what I'm going to do based on the way that I already set up my work for it. Or I could look at this junction right here, 2.1 amps going in, and if there's 1.2 amps going one way, I do 2.1 minus 1.2 gives us 0.9. So I know my answer here is going to be 0.9. Let me see if Ohm's law gives me the same number. Six divided by 7 is equal to 0.85714, which this number of amps rounds to 0.86. So actually, when I did that subtraction just now, I should have done 2.05714 subtract 1.2. The 1.2 was exactly 1.2, but this number was 2.057. So I would get 0.86 there either way. So that is for I2. So if you have the opportunity to use colors, maybe pencil crayons, that's maybe one way to help you when you're looking back on this work. You can see this number you got from this work here. That's a nice thing that you can do if you want to at home to help trace your work and double check. And you're of course going to want to double check that everything in this table has 2 significant figures, because out of the givens you had 2 significant figures and you did use multiplication and division somewhere in these lines. And that's how you do circuit analysis if it's strictly series, as in 1A, or simply strictly parallel, as in